Lesson 3, Troubleshooting Storage Performance Problems. At the end of this lesson, you should be able to describe storage performance problems, discuss causes of storage performance problems, propose solutions to correct storage performance problems, and discuss examples of troubleshooting storage performance problems. Overloaded storage and command aborts. If a storage device is experiencing command aborts, the cause of these aborts must be identified and corrected. Of course, I think we talked about this in the previous lesson. To monitor this, you look at the Performance tab. In the Chart options, you look at the commands aborted. If commands aborted are greater than 0 for any LUN, then your storage is overloaded on that LUN. Overloaded storage is generally caused by excessive demand on the storage device, or it could be misconfigured. Example, maybe you're not running jumbo frames. That's a big one I've seen before. Misconfiguration can occur in the configuration of the LUN characteristics. These are other examples. I've seen the jumbo frame one, but you can have the number of discs per LUN. So maybe we need to have more discs on that LUN to give it better IOPS. The RAID level of a LUN, the assignment of array cache to a LUN. So a lot of these you have to look more into your storage vendor, what vendor you're using, what type of storage, what can we do to fix overloaded storage. Slow storage. Slow storage is another common cause of performance problems. For a host LUNs, you need to monitor the physical device read latency and physical device write latency counters. If the average is greater than 10 milliseconds or they peak at 20 milliseconds for any LUN, you might have slow storage on that LUN. You can also monitor this for the DAVG/CMD and RESX top. Greater than 10, problem might exist. If it's greater than 20, a problem does exist. Factors affecting storage response time. Subsystem response time is affected by I/O arrival rate, I/O size, and I/O locality. Use the storage device's monitoring tools to collect data to characterize the workload and see whether it is a performance problem. What I generally do is I will go to my SAN or array, look at the counters there, and also look at the ones in the vSphere and kind of compare them, see if you're getting the same types of data from the counters, or close to the same. Unexpected increase in I/O latency on shared storage. When applications are consolidated, they share expensive physical resources such as storage. Situations might occur when high I/O activity on shared storage can affect the performance of latency sensitive applications. If you're running a VoIP server and somebody's copying a 2 terabyte file to the same virtual machine, or a virtual machine on the same LUN, you could end up with some unexpected increase in I/O. A very high number of I/O requests are issued concurrently. You have operations such as a backup operation in a virtual machine that can use the I/O bandwidth of shared storage. To resolve these situations, use vSphere storage I/O control to control each VM's access to I/O resources of the shared data store. Here's examples of bad disk throughput. Our megabytes written a second are 135, but our average command is 7.2, so we have low device latency. Output 2, bad throughput. We have our megabyte written a second is 3.95, but we have really high device latency due to the disabled cache. Example 2, slow virtual machine powering on. When you power on a virtual machine, it takes longer than usual. Check the disk metrics. Powering on virtual machines, really, they used to call them boot storms back in the day. When you boot up the machine, if you boot up multiple virtual machines at the same time, we call it a boot storm. Booting up takes a lot of I/O because you're loading OS files into memory. You might have to do a check disk or FS check, and booting an operating system can really tax a LUN. So if you notice it's slow powering on, check to see what else is going on that data store. You can use the web client to monitor disk latency. It'll give you a quick look at it. You can look at the disk milliseconds, and here we can see all it on 4/19/12 at 4 p.m. and right at about 4:08 we had some high. Right in here was getting around 145 roughly. We can see that we had some high spikes. It's not usually, our average is down here, and we have some little spikes right here, a little bit right here, but nothing really to worry about until right up in here. So that would be where we go and we see what's happening at those times that could cause that. And here it is. We can see it with RESX top. We have our 105 right here, another 105. Very large values for these metrics. If you want to solve the problem of slow virtual machine power on, you look at the performance statistics, but also look to where if there's any errors encountered on the host. So such as we lost connectivity to storage, we discovered data store shares. But see right here we have another lost connectivity. Now what I would begin to look at is maybe that SAN's getting overtaxed and it's dropping its queues because it doesn't have enough to handle it. Either memory on the SAN, the device queues on the SAN. It could be our device queues on our NICs. Just look to see we may have a packet storm. But generally, this would lead me a lost connectivity on storage. It's happening quite a bit. I would tend to be looking at the array and see what's going on there. Slow logins to virtual machines. You need to, if that happens, you need to, if you can't log into any virtual machine on an ESXi host, check to see that the virtual machines are saturating that resource, such as that ESXi host. Resource saturation occurs when each virtual machine's application reads from and writes to the same NAS device, and it's compounded when the NAS device is also a virtual machine. So check those out. Those are factors that can affect performance. Monitoring CPU usage. High or chaotic CPU usage can show that the host is saturated. I would tend to think in this example, what we have circled right here, yeah, this CPU, this guy's really working hard. That's an example of very high saturated host right there. You can just tell, even right here, he's doing a lot of work, but he's not maxing out. Here he's getting close to the top, and I mean, look at all these CPU usage from these hosts. Monitoring host disk usage. As you can see right here, we've gone down. Our disk usage average has went down, so well, there's nothing going on, so this is probably downtime of the environment. So I mean, we got it high right here, but it'll show you, you can look for saturation on the disk side as well. Disk throughput. Compare read and write traffic, help you identify what's saturating a disk. As we can see right here, this one, he's going like that. This host right, or this HBA right here, That was actually a host. These are HPAs. His disk usage on average, well, we're not even seeing it on the chart. It's in line with the red. I kind of see it a little bit right there. And as we can see, our disk read and write for this HPA, our writes a little more intense than our reads, which that's normal. This would be an example if we tend to see a lot of high writes and lower reads, we may want to look at what RAID level we're running on that line. Solving the problem of slow virtual machine logon. Look for CPU usage. It increases per virtual machine. The write traffic increases. Write traffic to the NAS virtual machine significantly increases. And virtual machines are so busy performing writes that they can never perform reads. When resolving storage performance problems, check your hardware for proper operation and optimal configuration. Check your array vendor to make sure. A lot of array vendors, they give you, here's how you will set it up to a Vsos6 environment. Do a lot of those checks whenever you set up your storage. Reduce the need for storage by your host and virtual machines. Balance the load across available storage. And understand the load being placed on storage devices. When resolving problems of slow or overloaded storage, follow these guidelines. Ensure hardware is working properly. Configure HBOs and RAID controllers for optimal use. Again, I would look and see what my hardware vendor or manufacturer recommends. And if possible, upgrade your hardware if it needs it. Storage performance best practices. Configure each LUN with the correct RAID level for virtual machines and applications that use the LUN. Avoid oversubscribing SAN paths and links. And use storage DRS and storage op control whenever it's applicable. Isolate your iSCSI and NFS traffic. Again, isolate them from your normal network traffic, but if you have iSCSI and NFS, isolate them on their own networks. And applications that write a lot of data should not share Ethernet links to a storage device. They need their own network. That's going to cut down your CPU usage on the host. And postpone major storage maintenance until off-peak hours and pause your backups. Eliminate all possible swapping to reduce the burden on the storage system. And in SAN configuration, spread the I/O loads over the available paths to the storage devices. And then strive for complementary workloads. You should now be able to describe storage performance problems, discuss causes of storage performance problems, propose solutions to correct storage performance problems, and discuss examples of troubleshooting storage performance problems.